side first, and then working with fractions by getting a common denominator, or sometimes separating one fraction into two. So strategy number 3, of course, complicated side, that can sort of depend on your opinion, and in particular on this example that we're doing, both sides are actually fairly complicated. So I could see some arguments for working with either side. But I think I'm going to pick this side just because it seems like there's a little bit more possibility there are these fractions to work with, and this allows me to work with strategy 4, which is when you've got fractions sometimes that are being added or subtracted, it's sometimes a good idea to combine them with by getting a common denominator. And so this one's a little bit messy. Basically, we can always get a common denominator simply by multiplying the two denominators that are already there. And so my new denominator is going to be this times this, and so I have to get the one that I'm missing. So this first fraction, is missing. That should be a 1 minus cosine of x, and so I have to multiply that on top and bottom, right? This one's missing the 1 plus cosine x, and so I have to do 1 plus cosine x on top and bottom. And so I'm really just multiplying each of those fractions by giant ones, and that's going to allow me to combine them into one big fraction, and that one big fraction is going to have this new denominator, 1 plus cosine of x times 1 minus cosine of x, right? 1 plus cosine of x and 1 minus cosine of x. What's going to be in the numerator? Well, the numerator is actually not too bad. We get 1 times this, so just 1 minus cosine of x, and then 1 times this, and so 1 plus cosine of x. And since I was adding the fractions, right, I'm adding the numerators, right? And so I'm still just working on the left-hand side. I'm not interacting with the right-hand side at all. I'm going to just look to see if I can clean things up a little bit. So one thing that's nice is I get a plus cosine and a minus cosine, so those cancel. And then, of course, I have 2 on the top. On the bottom, there's a few possibilities here. I could just leave those, but they're two things that are being multiplied. I see a squared over here, and so I can sort of see a possibility of getting a squared here if I FOIL it out. So I think I might try FOILing this out. And so, or you can use generic rectangles if you want to. If I FOIL, I get 1 times 1. In the middle, I get a plus cosine x. And on the outers, I get a minus cosine x. And then from the last two, I get cosine times cosine, 1 positive, 1 negative. So I get minus cosine squared of x. Okay, cosine times cosine. So again, I look to see if there are things that can be cleaned up. And I can see a little bit that can be cleaned up. And so I get the cosines to cancel. So now I'm left with 2 over 1 minus cosine squared. Well, it's not what I'm aiming for, so I still have to keep sort of plugging away. One thing, remember, from our last video is when we see that squared, we want to think about our Pythagorean identities. And in particular, we've got this Pythagorean identity. In the last video, we had rearranged it to get the cosine squared by itself. You can also rearrange it to get the sine squared by itself. And we see that sine squared would be 1 minus cosine squared of x. And so that's sort of handy, right? Because that's sort of a messy denominator. And so I can replace that 1 minus cosine squared of x with sine squared of x. And that's not too bad. So I see, though, that it's still not what I was looking for. And then when I see a sign on the bottom, I could think, well, maybe I don't like that sign on the bottom. Sign on the bottom, same thing as cosecant on the top. And so after all this work, I've done a really good job of simplifying, if I do say so myself, right? I mean, this thing was sort of messy at the start. I did a bunch of algebra, and I've gotten it down to 2 cosecant squared of x. But that's not what the right-hand side is. And so I'm sort of left wondering, well, how do I work with this? And so here's another strategy. The other strategy is if you work with one side and you sort of do everything you think you can with it, you can also work on the other side But the key is that you have to work on the other side separately. Sometimes people try and move things from one side to the other. That's not allowed when you're verifying identities because we're not sure they're equal yet. So we're just going to work on the two sides separately and try and meet in the middle. And so now I'm going to go back to the right-hand side of my original equation. And here I see this squared. So one more time, I'd like to use the trig identity, the Pythagorean identity. The problem with this trig identity is that it doesn't have a 2 in it, right? So it looks promising, but I have a 2 that I don't want. So the little trick to this one is these both have 2's. So I'm going to pull the 2 out in front, the distributive property in reverse. When I pull that 2 out in front, now I see the thing that I wanted, right? 1 plus cotangent squared from my list of identities is secant squared, cosecant squared. And so now I'm going to have 2 cosecant squared, and that's really good because I just simplified the right-hand side to 2 cosecant squared, and I had simplified the left-hand side into 2 cosecant squared, and so I had sort of met in the middle. I had the left-hand side, I simplified it to the right-hand side, or I simplified it to something, and I simplified the right-hand side to the same thing. And so I do truly know that those two things are both equal, and not only are they equal to each other, they're both equal to 2 cosecant squared of x. So that's sort of a tricky one.